In today's tutorial, we discuss classes and structures in Swift. The topics are class and structure definition syntax, instance of a class or a structure, declaration of an instance, accessing the properties of an instance, the introduction of value types, and introduction of reference types, and finally the identity operators. Similar to enumerations, Swift classes and structures are ways to create new types in Swift. For that reason, we should use capitalization when we are naming classes and structures. Both have storage capabilities in the form of variable or constants, and these are known as the properties of the classes and structures. Also, there are mechanisms within a class or a structure with which we can process the data, and these are called methods. Methods are effectively functions. Here's the very general syntax of a structure. We start with the keyword struct, the name of the structure. Notice capitalization here. Then within braces, the basic syntax will contain a list of properties. These are variables or constants defined for this structure, and a number of methods. These are functions which are defined for this structure. Similarly, for the class, we have the same sort of syntax. The only difference is the use of the keyword class. Again, notice the capitalization for the name of the class. The definition of a structure or a class is simply a blueprint for that structure or class. That blueprint is not directly used in the code. What is actually used is something called an instance of a class or structure. Swift uses the blueprint, which is the definition, to create different instances of classes or structures. As I mentioned earlier, this means that the class and the structure definition are not used directly. We can have multiple instances of a class or a structure. All of these will have properties and methods which are defined by the class or structure definition. Each instance will have their own set of properties and methods, and these are not shared by other instances of the same class or structure. So, for instance, for a structure defined like this, we have three properties called A, B, and C, and three methods called M1, M2, and M3. Then we could have multiple instances of this structure. In this example, I'm just showing two. This is not the syntax. This is just describing the idea. So we have the first instance of some struct, which is a structure, and then this instance will have its own properties, A, B, C, and its own methods, M1, M2, M3. The second instance, I2, will have the same properties with the same names, but these are independent. They're not shared. How do we actually declare an instance? Let's look at these two examples. We have a structure called SumStruct. It has 3 properties and 3 methods. And we have a class called SumClass, and it has 2 properties, 2 methods. The similarities between the names here are coincidental, and they don't mean that we are using the same properties or the same methods for this structure and this class. So now, how do we actually declare instances of this structure and this class? These examples show the syntax. For instance, here we are declaring a variable called x1. We follow that by the assignment operator. Then we use this initializer, which has the same name as the structure or class, followed by parentheses. This is the simplest form of initializer which is possible. I am not going to discuss how initializers actually work in this tutorial. We will be talking about those in future tutorial. So these would mean that x1 is a variable, and we are assigning an instance of the structure SumStruct to x1. The second assignment here is done by first declaring a constant called x2, and then we assigning a new instance of SumStructure to x2. So these two are going to be completely different in the sense they will have the same set of properties and methods as our structure, but these properties and methods are specific to x1 and x2. They're not shared by them. And the last example here is showing the case of declaring a variable called y1, and we are assigning to it an instance of the class SumClass. Now, the next question to answer is, how do we access the properties of a class or structure? Here I'm showing the example for a class. The same argument applies to structures. So, for instance, starting with this class, if we declare a variable called y and then assign to it an instance of some class, then this new parameter will have its own sets of properties and methods which are defined here. Now, if we want to access the property A of this parameter y, this is the format we use. The name of the parameter followed by a dot, and followed by the name of the property. So this arrangement here, y dot a, will return the value of the property a of parameter y and assign it to our new variable called x. So in this way we can read properties of parameters whose type is a class or a structure. We can use the same arrangement to set the values of the properties of a parameter which is of type class or a structure. So here y dot b is equal to 20 means that we are assigning a value of 20 to parameter b of y, where y as before was defined to be an instance of some class. Structures are value types. This means that if an instance of a structure is copied to create a new instance, the properties of the new instance are independent of those of the original instance. These two instances are independent instances. Each instance will have its own properties and its own methods. They don't share their properties and methods. This means that because of their independence, if the values of the properties of one instance are changed, the values of the properties of the other instance remain intact. So by changing the values of the properties of one instance, we do not affect the values of the properties of the other instance. Let's have a look at an example for this. What we have here is a structure called sum structure. It only has two properties, no methods. These properties are called a and b, and they're assigned values of 1 and 2. Now we declare a variable called x1 and assign to it an instance of some struct. That instance will have the same set of properties with the same values. So property a of x1 is going to have a value of 1, and property b of x1 will have a value of 2. Now if we declare another variable called x2 and assign to it the same instance of some struct which we assigned to x1 by just using this statement. So we are saying that x2 is equal to x1. This creates another instance of some struct, a completely independent instance, but all the internal details of that instance are going to be the same as those details of x1. So x2 will also have two properties called a and b, and the values are going to be 1 and 2. Up until this point, we expect that if we attempt to print the properties of x1 and x2, they would be identical. So if we print the property a of x2, we will get 1, and if we print property a of x1, we also get 1. Now if we attempt to change the property a of x2 from 1 to 10, Then we repeat the print statements here. So if you print property A of x2 after changing it, it prints 10, which is a new value of property A of x2. But when we print the property A of x1, we can see it's still at the same value as before, 1. So here we can see that the two instances indicated by x1 and x2 are independent. So x1 and x2 will have their own sets of properties and methods, and whatever changes we make to the properties of one instance will have no effect to the values of the same properties of the second instance. So this is the definition of value types, and based on this discussion we can say that structures are value types. When you copy one instance of a structure, you create a completely new instance of that structure, which have the same sets of properties and methods, but as I mentioned, they are independent. So we can do whatever we like to one of them, and that would not affect the other instance. One important point to point out here is that in the example that I showed here, the parameters that I declared, x1 and x2, were both declared as variables. But we could declare a parameter as a constant and assign to it an instance of a structure. Because x3 is instance of a structure and a structure is a value type, x3 stores an independent instance of the structure, as I mentioned before. Now, x3 is declared as a constant, and if we try to modify any properties of x3, we will see an error. The reason is that the parameter x3 is declared as a constant structure, not a variable structure. And this parameter will store a completely independent copy of the instance of that structure. So whatever change that we make to that instance, like changing the values of the properties of that instance, will change the parameter. But the parameter is defined as a constant, and by definition we cannot change a constant. So as a result we see this error. As I mentioned earlier, structures are value types, but the same cannot be said about classes. Classes are not value types, they are reference types. That means that if an instance of a class is assigned to a parameter, and then a second parameter is declared and set equal to the first parameter, both these parameters will refer to the same instance of that class and consequently to the same set of instance properties. So if the values of the properties of one parameter are changed, the values of the properties of the second parameter are automatically changed. This means that the two parameters are actually two different names for the same class instance. In other words, they are just references to the same instance. Two different references, but they are pointing at the same instance. Here's an example where we have a class called SomeClass and defined like this. If we declare a variable called x1 and assign to it an instance of SomeClass, then we declare a second variable called x2 and set it equal to x1. Like in the previous example, if we print property A of x2 and property A of x1, we get 1 as the result of the print statement. Now, if we change property A of x2 from 1 to 10, like so, and we repeat the print statements, we will see that when we change the property A of x2, the print statements will print 10, and then when we try to print the property A of x1, we can see the value of that property has also changed from 1 to 10. So by changing the value of a property of one of these parameters, the value of the same property of the other parameter changes with it. So in this case, x1 and x2 are only two names for the same instance of the class. They are not names for two independent instances. Now, like in the previous case, where I mentioned that we could have a parameter declared as a constant, we can declare x3 as a constant and assign to it an instance of a class. Then x3 is a reference to a class instance, and a class is a reference type. This means that x3 does not store the actual instance of a class. x3 is the name, it acts as a pointer to that instance. It doesn't store the instance itself. It doesn't store the properties of the instance. So when we try to assign a new value to a property of x3, we do not see an error. Why? Because the change in the value of A does not change x3, which is just a pointer to the instance. Here the instance is changed, but the pointer to the instance is not changed. So as a result, we don't see an error. So in short, we have a parameter which is declared as a constant reference or a constant pointer to a class instance, and this parameter does not store the instance, and it does not store the properties of that instance. So whatever change we make to that instance does not change the parameter itself, because parameter is just like a mere pointer. So as a result, the instance properties can be changed, for example, using a statement like this. And this would change the instance itself, but it does not change the constant reference. As a result, x3, which is a constant, remains as before, and we won't see an error. This is unlike the previous case when we were dealing with constant structures. When we're dealing with classes, we can use two identity operators. The first one comprises 3 equal signs. The second one starts with an exclamation point followed by 2 equal signs. These operators are used to check whether 2 parameters refer to the same class instance. It is important to note that these identity operators can be used with classes, which are reference types, and cannot be used with structures, which are value types. As an example, let's have a look at this class. Like before, we declare 2 parameters, x1 and x2, and these are 2 names for the same instance of class SumClass. We also declare a new variable called x3 and assign to it a completely new instance of SumClass. So these instances are independent and different. So if we use the first identity operator to check whether x1 and x2 are the same names for the same instance, the answer is yes, because x1 and x2 are the same names for the same class instance. So this would result in test1 to be equal to true. If we tried the second identity operator to check whether x1 and x3 are not the same name for the same instance, they are actually names for different instances of some class, the answer would still be true, because x1 and x3 are reference to 2 different instances of the class. So x1 and x3 are not identical because they're not referring to the same instance, even though the instances are equal in terms of their properties. That means that if we look at the properties of x1, you can see this, the values are the same. x3 will have the same set of properties with the same values, but this set of properties are completely independent of the set of properties of x1. So because x1 and x3 are not referring to the same instance, they're referring to 2 independent instances, they will not be identical. So this statement will return a Boolean true, which is assigned to test 2. As a final point of today's tutorial, I'd like to mention that many Swift types are implemented as structures. These are the types that we have already seen, and some of them are listed here. Integers, floating point numbers, booleans, strings, arrays, and dictionaries are examples of Swift types which are implemented as structures. This brings us to the end of our today's tutorial, which was an introductory tutorial to structures and classes.